In this video, you'll see how I build a brand new electrical and service that's being relocated from one side of the house to the other. This new service is going to be a 200 amp Mast service, which entails going through a roof with conduit and using that conduit as support for the service drop from the electrical utility Pseg. If you like watching electrical work, I know you will like this video. Let's get started, and don't forget to like and subscribe. So the first thing I need to do here is set up my ladder, and then I get out my SDS Plus drill and I make a small hole, maybe it's like a 5/8 hole, through the soffit to scope out above the soffit so I don't hit any framing with the 2-inch piece of rigid metallic conduit I'm going to be using here for this service mast. Now the 2-inch size is the required size conduit for a Mast service, and for this particular utility company, which is Pseg. So once I drill the hole through the soffit, you see the hole there in the roofing shingle. That's where my hole is going to be. So now I'm going to make the hole a little bit larger so that the conduit will fit in through it. So truth be told, I make this hole and it's just a little bit off, so I have to take my Sawzall out and make the bottom half of that hole a little bit larger so that the conduit will sit flat on the wall going into the top of the meter. So the recording of this took place the second week of July, and it was by far the hottest week of the summer. I mean, it was really brutal out there, and this is the first time I've actually ever brought a tent with me to the job, but it was appropriate here because it was so hot and I had enough room to set it up and work with it. A lot of times you're going back and forth to the truck, in and out of the house. There's no sense in setting up a tent outside if you could have all your materials and your tools, your drop cloths, etc. inside the house. So I set up the tools, I set up the tent here and the table here on my jacks, and I had plenty of room to work. So this is Pseg, and so you have to follow all Pseg's requirements for Mast service. And if you'd like to see the link for the installation guide for Pseg, I've left it in the comments. I'm sorry, in the description below. So be sure to check out that link if you're curious about anything going on with Pseg. This will be for the feeder right here that goes to the load side of the main breaker here. And we'll get our number 2 grounding electrical conductor to the water main, and this will be the ground rods. And that's how we take care of all the grounding here. So in that enclosure is all of our grounding and bonding. The number 6 copper for our ground rods, the number 2 aluminum for the water ground, the equipment grounding conductor for the house, and of course the grounded conductor from the utility. I used the drill to mark all of where my holes are going to be. Then I drove plastic anchors and number 10 panhead screws to attach this meter main to the stucco. This is the first time I've deployed this tent. I bought this tent maybe like 2 or 3 months ago before a concert of all things. And I realized that I could bring this to work with me on a hot day. Unfortunately here, I'm in the shade, but as I found out after lunch here, the sun set on the other side of the house. And so the tent was up, but I was in the shade anyhow because of the position of the house and the sun later in the day. All right, so here we are through the top of the roof where the mast is, and I got my camera set up on a flexible mount here on the ladder, which is how I do this. But something happened to the footage. I don't remember what. I wanted to show you more of how I attach that flange underneath the roofing tiles, and unfortunately I don't have that. But I will tell you that the roofing they're getting a new roof put on this house, and they're just waiting for me to finish up this work here so they can do it. But I assure you that it's weather tight, and we came back and we caulked it, and it's not going to leak. I'm using 2-inch lag screws here, 1/2-inch lag screws, to attach it through the stucco and then to the sheathing behind the stucco. And so the idea when you're using a mast for support of your service drop, you got to make sure that you have at least 2 straps on that conduit that pokes out through the top of the roof. As you can see here, this is just one piece of conduit because I realized a few hours into this that I don't have enough 2-inch rigid for the height requirements for the service drop. And so while I was 2 feet above the roof, I really needed to be 4 feet because the service drop needs to be at least 3 feet above the small section of roof that's not really accessible to walking, but somebody could walk there. And then of course up at the top there, you want to make sure you get a couple straps into the framing to secure that mast coming through the roof. The mast will also require a guy wire, which I have yet to install, but I'm still waiting to set the appointment for the inspection. And so what I'll do is I'll meet the inspector out at the house here for the inspection in case he has any questions at all, since this is kind of a unique service upgrade, since it's a brand new service and we're relocating it. So I wanted to be there for it. So I got to put in that guy wire, and then you'll also notice in this video that I didn't identify the neutral conductor up at the weatherhead. And the reason why I didn't do that is because I didn't have any white tape with me on that day. So I originally marked it with pink tape so I knew which one it was. And then when I came back to tie in the meter enclosure, at that point I used the white tape to identify the neutral conductor inside the meter. But I forgot to identify the neutral up top. So when I go back, that's what I'll need to do to get the approval on the inspection. Utility here, Pseg, requires that that meter be 6 feet to the center of the meter for mounting height. And so just like any other service upgrade, this upgrade requires 2 ground rods and of course a connection to the copper water pipe that's buried a minimum of 10 feet inside the earth. We connect that and we use that as a primary grounding electrode for this electrical system, making it solidly grounded. I'm installing my number 6 copper grounding electrical conductor to both of my ground rods as required by the code. I always try to make this stuff look as neat as possible. In reality, the number 6 copper grounding electrical conductor for the ground rods just has to be buried, 4 to 6 inches deep. I'm not even sure if I got that much here with this gravel. In fact, some of the gravel was so shallow that I didn't want to rip the landscaping fabric beneath it. So I think what I need to do is bring some stones back and add some stones behind here to make sure that the grounding electrical conductor here for the ground rods is actually buried, and so nobody can trip over in the middle of the night. But the idea is that the ground rod's supposed to be buried beneath the earth, but you need to leave it up so the inspector can see it, or dig around it. So I usually leave it somewhere around the middle of those two areas so we can see it. And there's a lot of other stuff around here, so as long as we can see it, I think we'll be good to go. Then we can come back later with a sledgehammer and drive it down, or what will likely happen is we're just going to leave it like that. Here's the bonding bridge that I've been using a lot lately. And so what I do is I strip back the number 6 conductor, and then they have this set screw here so that this is absolutely bonded, even though it really is bonded to the enclosure with the lock nut up above. The directions say to use this set screw to attach it so that the piece becomes bonded to the system. And what it does is it's there for the grounding, auxiliary grounding electrodes, like your cable television or your cable modem. You want to make sure you have those protected and grounded as well. So it might look like the whole enclosure here is moving, but I assure you it's the camera on the tripod that's like right beside me. I'm trying to get a good angle here, and I'm trying to get the work done, so I'm not here until 8 o'clock at night. So that's just me knocking in, or the wind actually blowing around the tripod. So what I didn't show you in the first part of that video is that my service mast was not high enough. I planned on installing one stick of 2-inch galvanized conduit, which is 10 feet long, and from the top of the meter to where the weatherhead was going to be was 10 feet, but we were only 2 feet above the roof line. And because there's a walkable roof and service entrance conductors would be going over the roof right there, the service drop needs to be 3 feet over that roof. So I wound up taking down this one stick of galvanized and cutting a 2-foot section to add to the overall length at the top by the roof, so that I was 4 feet above the roof line, meeting that requirement by Pseg. So I'm marking here my galvanized conduit to cut it, and then I'm going to install a threadless galvanized 2-inch coupling, and then I'll have the adequate height requirement as required by Pseg. So what I'm doing here is I'm backing out the old conduit so that I can cut it in place without taking it out from the flange up on the roof. This was actually a very costly mistake because another stick of 2-inch galvanized cost about $90 now, and this threadless coupling that I'm using, obviously it's a compression coupling, was over $80. So that was quite a mistake. But when you're building these things, you do the best you can, and I really regret making this mistake, but I don't regret making this change now rather than having the inspector say you fail because the height's not high enough, or worse, the utility company refusing to connect the new service drop. That would not look good. So you bite the bullet, you do it right the first time, and that's that. By the way, if you like this video and you like this content, do me a favor, hit the like button and also subscribe. And of course, you know about the notification bell so that when you open up your internet browser to YouTube, you hit that notification bell and the video will be shown on your homepage when you open up YouTube. You can do that by hitting the notification bell, and I appreciate it. Thank you very much. You also may have noticed that I bought a new extension ladder, and it wasn't cheap, but you have to do this maybe every 5 years. If you're an electrician or a plumber that leaves the ladder on top of your roof, the life of the ladder is probably about 6 years. Once it starts falling apart, you can see the fibers of the fiberglass. It's time to get a new ladder. So here I'm using 1/2 inch by 2 inch lag screws to attach this strap to the conduit in through the framing. The last thing we want to do is have that conduit actually be pulled away from the house for any reason. So this thing is put in there so solid. I don't even think I need to put the guy wire in, but I'm going to do it because of the height of the mast. But that'll be in the next video after this one, when I cover going over the relocation from Pseg. So this is my 2-inch weatherhead, and it straps onto the top with a pressure clamp there. And then we poke out the holes through this plastic grommet, and that's where the service entrance conductors poke out from. Having a new ladder and a safe ladder, especially an extension ladder, is very important. I apologize for not having the best camera work right here. Like I said, this is the following day, and it's late in the day here now because I had something to do before I got back to the house on the second day. But this rubber grommet goes over the galvanized conduit and then down onto the flange, and that's supposed to keep some of the weather away. Now, I do got to tell you, if you saw the size of that hole that I cut out for the mast, yes, it is large, but I had to do that to get the conduit to sit flush, or to sit flush on the wall below. The roof here is getting completely redone, all sides of the roof. So the good news is, whatever I did here, the roofer will take care of it, and it will be watertight, I can assure you. They have a very experienced roofer coming to redo the roof, and I have all the confidence in the world that it's weather tight now. It'll be even more weather tight once the new roof is in. So you want to slide that rubber grommet down, and then this is actually the clevis hanger, the porcelain hanger that the utility will tie their grounded neutral to. You'll see I flip it around to the front here, and that's how it gets its support from the overhead service conductor drop from the street. That's how that'll sit there. I tell you what, that pipe is very solid. And so the service set, so I got the camera in one hand, I'm working one-handed here so I can show the viewers what I'm doing, but really I should have gotten my other GoPro clamp here to get a better video of the installation. So then once that's done, I'm ready to walk out my 4/0 aluminum, and one by one here I will send the conductors up through the mast and very carefully cut them so they're each equal length. Pseg requires at least a minimum of 2 feet coming out of the weatherhead up at the top there. I probably left about 3 feet because I think that's an NEC requirement, but I could be wrong. It's aluminum wire. I'm not going to say it's cheap, but it's not as expensive as the copper. And you just want to make sure you have adequate free air conductor space up at the weatherhead. So the service head, when it gets tied onto, there's no issues at all. So the Klein ratchet cutters, I highly endorse that tool. That works very, very well. Milwaukee makes some battery operated tools, but it's just a little bit more than my price range. I do a lot of these services, as you know. I would love to have the crimper and the cutter, but the justification of buying a $3,500 tool just for that reason, I just can't justify it at this time. Hopefully Milwaukee is watching this video and they like it and they'll send me one for free to do a review. We'll see. I'm not holding my breath. In fact, I have a Milwaukee rep at the Independent Electrical Contractors Association I'm somewhat close to, and I can reach him by email with any questions of a product that I might have, but I'm not going to ask him to get involved with that. He knows I do the channel, and if his company says, yeah, give him the tool to do a video, I would love to do that, but I'm not going to hold my breath. All right, so there you see the pink conductor right there. I did not have my white vinyl tape with me that day. So when I come back the following day, on Monday over the weekend, after the weekend, I'll put the white tape on and go from there. I really wish I had taken the time to get the mount for the GoPro so I could attach it right to my ladder. It's an adjustable clamp. It's definitely a great mount for the GoPro, but this is what I got right here. And so the idea is once you poke the holes in this, I don't know what you want to call this, the black, that thing right there that the wires are going to go through. I don't know what they call that. But this is kind of tricky. Usually I have a PVC weatherhead, but what I needed to do here was poke out those holes and have all the conductors poking through so it sits inside the weatherhead, then you put the cap on. And to be quite honest with you, it is kind of a pain in the ass to do, especially when you're trying to be careful not to drop your GoPro camera and break it, but I do the best I can here. The next step in the process here of completing this service upgrade is to get that large cable there. That's a 4-wire, 200 amp, what we call service entrance riser cable. So it's got 2 hots, a ground and a neutral. And I need to get it from this side of the house back over to the other side of the house where the original service is now. And so you have to plan this out the best you can. Here I am working on my own. So I was able to go in the basement You can see the existing cables up above me right there. Those are going out to the generator and going directly to the transfer switch, which is where I'm bringing this new cable from. Now, we probably could have relocated the automatic transfer switch, and then we wouldn't have to run this long wire, but then we would have to supply the power to both of the existing panels. So I thought this job over very well, I believe, and I thought this was the best solution, to leave all the existing electrical equipment inside the house alone and then resupply the transfer switch. I thought this was the best way to go. So as you can see here, there's a finish suspended ceiling, which was nice. I didn't have to cut any sheetrock. And so basically what I did was I followed almost the exact same path that the generator installation used, knowing that that was a way from one side of the basement to the other. And so I take apart these ceiling tiles and very strategically pull the cable from one side of the house to the other. This went a lot easier than I thought it would go, and I was actually very happy with the results. Yeah, so as you can see here, they've added this high velocity air conditioning equipment. I think that's what you call those pipes right there, but they're real small. Very common in an old house like this. By the way, this is the same house that I worked at in a video earlier where I did the wiring inside the basement. I'm sorry, not the basement, in the garage. This is the same house. So this house was built in 1909. So you're really limited with the options of what's available to you to get work done. So I thought this was the best way to do it. So I used a lot of these. You can see the braces that go from the joist to joist. And those braces are there to keep those joists sturdy in the event of an earthquake, so the floor doesn't collapse. I believe that's the intent of those framing, what would they call them, braces. And so here I'm just using 1¼ inch PVC straps to secure the service entrance riser cable. And you're supposed to secure this cable, I believe, like every 5 feet or so, without looking in the code book. It might be 4 feet. We're above the suspended ceiling there, and I'm confident that it's not laying on the ceiling directly. We went through several of those braces, and I put in more clamps that I'm showing in this video. But it was all done in a nice, neat, workmanlike manner. And of course, the length of this service entrance riser was actually 75 feet. And I'll tell you what, I was maybe 6 inches to a foot longer than I needed to be. It was just right. You know, you measure, but there's always something that comes up. And you would hate to have, I would have hated to have done all this work and found out that I was a foot short and I had to do something to adjust it. Otherwise, I'd have to buy a whole new cable and reinstall it. But it worked out just well. Here's my water ground connection. And now I did video for this, but it didn't come out very well. So there's the copper water pipe going into the ground, and then we just jump from one side of the meter to the other side of the meter to meet the requirements for a grounding electrode system. And so now I'm going to poke out the concentric knockout to get my 2-inch male adapter. And what I'm going to do is I'm going to attach a small piece to the bottom and install this LB, and then we're going to sleeve the service entrance riser cable through the conduit. And of course, you need to have a clamp at the end of that to clamp the service entrance riser. So at some point, somebody added this lattice for the detail underneath this porch here. I'm not sure if this is an addition to the house or not. I'm not sure. But I had to notch out a small section of that frame that actually holds the lattice. You can see the lattice in the background. It's similar to that. So I just had to notch that out to run my conduit here. And this worked out well. See how I just sleeve it right through? And then once it's in place up here, we'll glue it up. You would never want to glue anything until you know for sure that this is the exact measurement that you want. Otherwise, you're going to have to replace that LB. And I think that PVC LB is probably about $30 these days. Maybe a little bit less. Nice, again, the 2-inch lag screws here to keep that secure to the framing. That thing's not going anywhere. Eventually, I get back in there and I do another one. Here you go. I'm laying on my back here, and it is dirty as can be. There's really not a lot of room there. But if you're going to do the things that other guys don't want to do, no matter what your trade is, you will always have a job, and you'll always work. And good things will come your way when you do things that other people don't want to do. That is one of the greatest lessons I've learned in being in the trades, is to do those things. So if you're starting out and you want to get a leg up, do something that the other guys aren't doing, and I guarantee you, you'll be successful at it. All right, so now that I got the right adequate amount of conductor through the LB, I'm going to come back with another 2-inch strap, and we're going to attach it with the 1/2-inch by 2-inch lag screws. All right, so you're never going to bend all of that wire assembly at once through the LB, but because it's protected by the PVC, it cut it back, and then I went with one conductor at a time up into the main disconnect here. And there's a nice tip. If you're having trouble getting that wire through and getting that bend in there, use the butt end of your hammer so you don't damage the insulation. Somebody showed me that a long time ago, and I still use that trick like every day. Or anytime I have to, obviously. Hey, if you're enjoying this video, do me a favor, hit that like button. And if you want to see more of this type of content, subscribe and hit the notification bell. Be sure to leave your comments in the comments section too. I like replying to the comments. Some of them, I don't want to say they're stupid, but some of them could be a little ridiculous. There's a lot of armchair electricians out there that think they know everything. Things are different in New Jersey than they are in Wyoming, for example. Different weather conditions. So what you might not be able to do in Texas or California, we could do here in New Jersey because of the climate. It's different climate up here. And, well, so there you go. That's underneath the porch. Everything strapped and secured. And we should be good to go for the inspection coming up. Hopefully next week. I have to schedule that. So here in New Jersey, some towns require that you schedule the inspection online. This thing called the SDL portal, which is nice, which has come up since in the last 15 years. When I started, we didn't have that, but soon thereafter, in 2010, 2011, we were able to send in, we were actually able to print out our permit applications and then send them in. And now there's this thing called the SDL portal where you can actually make the payment and get alerted that your application has been approved and you're ready for payment, which definitely speeds things up. We still cannot apply for permits online because here in New Jersey we have what's known as a seal. So when we put together our permit application, we have to seal the electrical subcode permit. And to do that online, I think they're still trying to figure out how we're going to do that. So for the time being, now we just seal the permit and I mail it in. And then some towns do the SDL, they're up to speed, and other towns are not. Some towns still require a fax instead of email, which is, boggles my mind because it's not 1995 anymore. So I'm using Panatrox here and I'm tightening down my loads. The service entrance conductors, there's two in the middle there, are attached to that 200 amp main breaker, and I'm going to attach. It's very important that you terminate these conductors in an order where accessibility to the lug is prevalent. For 1 and 2 family dwelling units, all service conductors shall terminate, and disconnecting means having a short circuit current rating equal to or greater than the available fault current installed in a readily accessible outdoor location. If more than one disconnect is provided, they shall be grouped. Each disconnect shall be labeled one of the following. And so what I'm doing here is I'm putting up a couple of labels. It says main disconnect and service disconnect. So there is no confusion on what this switch is actually doing here. Hey guys, thanks for watching this video. If you watched this all the way to the end, I really appreciate it. We'll see you on the next one. I hope you enjoyed this one. It took me a while to get this one out and put together. Thank you. Thanks for watching this video. Be sure to subscribe, and we'll see you on the next one.